Hello everyone. So today we are going to see one of the most important topic from data structures and algorithms, that is linked list. So what is this linked list? The name itself specifies what is this linked list. Uh, Simply a list that is linked or interconnected between it. So basically from taken example, we'll see it. When we By taking an example, we can see when we declare a variable in our code. As you might have prior knowledge how to declare variables and arrays. So when we declare a variable, a memory space gets allocated. Suppose what we'll do is we'll just declare, if we declare int a is equals to 4. So the thing is that when we declare int a is equals to 4, a memory block gets allocated in memory, and whose alias name is a, and whose value is 4, while the address, this suppose the address of this memory block is 100. So this a can be accessed by its address too, because address specifies the memory block, right? So now moving on to the next thing, if we declare an integer array of 3, so what will actually happen in the memory is a contiguous memory block will get allocated, in which this will be the array, and it will be like, suppose if this is 100, so this will be 101, and this will be 102. Now this is a contiguous memory block. There can be many blocks from this and this side of the memory. So the condition here, we say why to use linked list. Now the condition here is we have to declare the size of the array before or on compile time. That is, we cannot just randomly write int array bracket bracket. We should declare its size first. Suppose if we just want to add one more block here, we can't add it in array. This is not possible. This is not possible in array. Now this is the case where linked list comes in handy. Now formally, if we talk about linked list, so linked list, what is linked list? So basically, linked list is linear data structure, which in which the elements are stored in random memory locations. It is a linear data structure in which the elements are stored in random memory locations, and how the memory gets allocated in linked list is it is allocated dynamically or while runtime. Now these words like memory allocations, dynamically, runtime, these might seem fancy, but we'll sort it out step by step. Now, getting over with memory. So, memory has blocks which are represented by unique addresses. So, simply, if we just imagine how can we memory look like, so this will be how a memory. This is how a memory is. So there are numerous blocks in this, which will be addressed by 1, 2, 3, 4, and dot 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 till n. Okay, and this will be continue from here, and this will get continue over there. So this is how a memory looks like. There are kind of blocks which have the address to represent themselves. And when we declare an array, or if we declare int 4 as we seen here, so the memory gets allocated like this. As integer, it has 4 bytes of memory, 4 bytes of size. So these 4 bytes will be allocated for int a. So this will be int a. This is how memory gets allocated in when we this is how memory gets allocated when we declare a variable or an array. So what happens when we declare a linked list? So consider this memory. So this memory has several blocks in it. When we declare a linked list and when we try and insert an element in it, so one element, if we insert 4, then it will get allocated in here at a memory uh, at the memory address of suppose 10. And if we try and insert 5, so there is no guarantee that it will get inserted here. It can get inserted here also. This can be 5 with memory address of suppose 15. The third element can get inserted over here, as this might be free. So this will be 6 and this could be suppose 100. From this what we can understand that the memory getting is getting allocated at random positions, 10, 15, 100. Now in an array what we can do here, we can see that in an array, if we have this, the starting position of the starting address of the array, we can easily access by just adding one. We can just simply access this array from the starting address, right? As they are contiguous memory blocks one after another. But what about linked list? What specifies that after this 4, we have this element at address 15. So there is a concept called node in linked list. What is this node actually? So a node is something like this. It has two parts, in which one is of data and the other is of pointer. This one represents data that we are going to store, which can be anything like integer, float, string, character, any data you want. And this one represents the pointer. Now, what is a pointer? Pointer is something uh, in which addresses are stored. Like we are storing data or value in numeric values in integer data type, such as addresses are stored in pointer variables. So what happens? So this is the structure. So this is the actual structure in so this is the structure that is we are going to work with. There's a node which has a data and a pointer. So there's one part, one memory block that is divided into two parts, data and pointer. After that, what we can see from this linked list is it has many advantages. Suppose if you want to insert array after this 4, 5 and 6, if you want to insert the fourth element, there's no restriction that you cannot insert in it. We can insert it as per the memory is available. Suppose we want to insert this fourth element. We have inserted this 7 in here. Suppose it is 80. So we inserted the fourth element in here. If you want to remove this element, we can remove this element. There is no restriction in it. After that, but one more thing, array, we cannot increase this. As I already told, we cannot increase this. So there can be one more option, like you might tell, is we can declare an array of 10 and use and simply use 3 space from that. But what about remaining 7? The memory has vested over here, which is not good. Memory, we should not waste such memory because it is allocated. This memory cannot get allocated to other resources too. Even it is free, it cannot get allocated to other things. Now, As you might have cleared this concept of linked list, which in which we need this node, in which we are going to work on this node. So moving on to the linked list implementation, we are going to see linked list implementation in Java. So you might know the basic syntaxes of Java. Let's just create a file, linked list dot Java. Here what we have done is we have been in Java we use camel casing. So we will declare like this, and we'll create a class called linked list. So we have created a class linked list in which we'll write public static void main. So in this we'll write public static void main. VS Code comes handy while writing codes of Java as it has longer syntaxes. So what we are going to do is we have created a class linked list. Now we have to create this node, What does this node has? So let's create a class public static node. So what this class will have? So basically this class will have something like sorry. So let's create a class. What we need is uh, what we need to create a node class in which the member should be data and the pointer. So let's create a public static class node. So we have a node class in which what we are going to do is we're going to declare into data, the data which we are going to store, and the pointer to the next node. Now why I have taken this node, why I have taken the node as a data type. Now basically when this linked list works, it works like this. This is the data 1, 2, 3, 4, something like this. And this is suppose another, this is at 100 position. This is suppose at 200 position. So 200 address is there. So we store the address in here. So this position will consist of 200, which means that this will get linked. This will point after this node, this first node, we have this second node to go ahead. So here we have taken node next. That is, this next will point this node's address. Now we'll just do a simple constructor. We'll declare constructor node into data, which we're going to set. This dot data equals to data. Now I have used this in here because the variable which we have passed or the parameter is similar to the data or the variable instance we have created in this class. So this specifies this class instance of data. This data will specify this data, or else we can just do like d d, and this will be d, and the next value will set it to null. Now moving on to the next thing, one more thing, the starting. Now this is a linked list, right? This is whole linked list. Okay, when a linked list ends, the last value is null. That is, it won't point to anything that will specify the linked list has ended. Now one more thing, now here we will call the start of the linked list as head. So this will be the head of the linked list. So we'll specify the head as something like node head. So we have specified the head of the linked list from which will from where the linked list will start. Now the next thing is we'll just create, and what we'll do is we'll create an object. We'll create an object of linked list equals to new linked list. So we have created an object. Now basically what we'll do is we'll just uh, do the menu program for the user to better play with linked list. So we'll just declare the required things like data and choice to get here. System without, what we'll have is something like one. Now there are various operations we can perform in linked list. So linked list can have operations like insert, command, delete, display, display. Many similar operations like array, but what is the thing is we can insert at any position. Suppose starting at the nth position, suppose the starting of the linked list, that is near the head, starting of the linked list is at the nth position as at the end. Even similarly, we can delete. We can delete like that. Suppose we want to delete the first element, we can delete the nth element in the linked list, and we can delete the last element, and we can display the linked list using pointers. As we have this next, this is going to get quite handy for us to traverse over the linked list. So the next thing is that while implementing, so moving on to the implementation. So moving on to the implementation, what we'll have is we'll just use insert at end. So insert at end, and we'll have something called, we'll have insert at end, and then we'll have display the list, and then we'll have exit. These options will keep while starting, and then we'll get a while loop, which will get through always until and unless we get an exit from it, and then we'll just set the input, enter your choice. So we'll take the user input from here, and we'll just do choice equals to, now what we need here is we need a scanner. For the scanner, what we need to do is we'll just import java.util.start. So this util package has the scanner method, which we will just scanner class, and just create a scanner object, new scanner, and system.in, as we are going to have the input from that. So choice is equals to scan dot next int. And these are the basics which we learn in Java. While these are very basic things that we learn in Java starting. So we have got the choice. Now we just need to write a switch in which the key will be choice. Oops, sorry, choice. Then the value will be 1, and then what we'll do here is we are going to insert a time. So we'll just call list dot insert at end, and what we are going to do is we have to pass the data in it, right? So we'll just input the data, enter the data to insert in list. Oops, insert in linked list. So data is equals to scan dot next int. So we have inputted the data needed, and now we're going to pass this insert at end, and the data is going to be passed to the thing, plus we are going to pass the list in that. Now what is this actually? Now this is a object method that we are going to declare in here. We'll just declare it public void insert at end. So what we have passed the parameters is we have passed the data and we have passed the linked list object. So this is a method and this is the data and the linked list object that we have passed from here, and we have this in here. So now we'll just get on with the insert at end code. So startingly we don't have anything, right? So we need to create this node. Now how to create this node? We'll just create by creating its object. Simple. Now how to create this node? Simply by creating its object. So let's write node, new node equals to new, and we have the node and in which we are going to pass the data. So what actually has happened here is this data has got inserted into this node. Here the data is there now. The data has come now. And this pointer, the pointer which we are going to store the next node address is quite now null. So now what we'll do, we'll just check if the linked list is null or not, so that we can define a new head for our linked list. Now we'll just do if list.head is equals to null. List.head is null. So what we'll do is list.head is equals to new null. Now what has happened actually is we have declared this new node as our list head. So this node we have declared now, this comes handy over here. So this new node which we have created just now is our head now. So now this what is this for? This is for the first node to be in inserted in the linked list. Now what if we have to insert the next node? Now the next node should get inserted in here, right? We have created this node. The next node should get inserted like this we have created a new node by calling new node and creating its object. So this should point in here, right? This is called insert at end, right? What I specified. So now let's get on its implementation. Okay, if this is not there, right? If we have a head, already we have a head, then what we do is just create a node of current. This is the current node in which we'll store list.head. And then what we'll do is we'll traverse the linked list until current dot next is equals to null, is not equals to null, and current equals to current dot next. So what I have written is actually, so we have just defined this as current. This is the head actually. We have defined this as current. Now what just happens is while current dot next is not equal to null, this current, it will check that if this current next is null. No, it is not null. So what will happen is current equals to current arrow next. So this current will be assigned the value of current arrow next. Now what is current arrow next? Current arrow next is this node. So now after this one iteration, what will happen is our current will change into this. Now this is our current and this is not our current. So this is our new current. So now then again it will check that if current arrow next is null. Yes, here our linked list has ended and this is null basically right now. So this loop will get out, that is it will be terminated, and then this current node dot next equals to new node. Now what is this actually? Now we are at this current node which has this pointer has, we'll just take a dark color. This pointer This pointer is null right now, right? So we have created this new node. Now how to point this to this? So what we have just basically done is current.next is equals to new node. This new node means it represents this address actually. If it, suppose it's on 200 address, so this pointer variable will store 200. That is, it will get linked to this and this basically, and this points to null already as we have declared in the constructor. So this is how we insert at end, and we'll just quickly write the code of display. It's not late void display. So we'll declare method display, and display is very simple. We just have to traverse through our linked list. Okay. So what we'll do is we'll just pass the linked list link. Oops, sorry. Linked list object as linked list, and then we'll just check that if the list is empty, if what we'll do is we'll just check the type. If type equals to null, the linked list is empty. System dot out, the linked list is empty. Now else, now the linked list has some elements in it. So what we'll do is we'll just create a node current equals to list.head. So we have just created a current node which has list.head in it, starting pointer in it. Now we'll just do system.out and println this is our linked list that is going to be displayed, and then we'll just iterate along it like we have done here until null. Similarly, what we are going to do is we'll just do current until current is not equals to null, current equals to current dot next. Oops, sorry, current dot next, and by traversing through the current node, that is the shifting node, we'll just system.out the println, we'll just do a space and plus in current dot data. We'll just print the data over there. And just lastly, we'll just print a slash in there so that we'll get a proper spacing. Now let's just try and implement this. So we have done the insert at end. We have done this insert at end method also. We have defined it. Now what we need to do is we need to add the case 2, right? Our case 2 is something display. So we'll just call list.display, and already the list has been passed over there. This is quite good feature of VS Code, so I do prefer to use it. And the case 3 is something we know as exit. So exit is something we write as system dot exit bracket 0. So this is how we exit from a code, and the default will write as system dot out enter a valid option. Done. We are done. We have implemented the linked list. Now basically why this has come. We will just run .java. We'll just do it. Now see, now we have our options. We have the menus over here, insert at and display the list and exit. So we'll just make it quicker. Insert at and display the list and exit. Now what's our choice? What's our choice? What's our choice? We need to insert an element. We need to just insert 10, and let's see if we have, yes, our linked list has the 10 element. We'll again insert 20, we'll insert 30, we'll insert 40. Let's see our linked list. 10, 20, 30, 40. We have the linked list. We have the data elements. Now we'll just exit the code, and this is how you implement. This is how you implement linked list in Java. See you soon.